Hey guys, I'm going to go through the FRQ for the upcoming test on Chapter 4. This will be the only one that will be on the test, although I might adjust values here and there, but we'll see. So the question states that the depth of water in a zoo aquarium at a certain point is modeled by the function W, where Wt is measured in feet and time is measured in hours. And we have this kind of piecewise function given here. So find W prime of 7 using correct units. Explain the meaning of W prime of 7 in the context of the problem. So notice the value of x that we're taking the derivative of, and because we have two different parts of W, we're going to take the derivative of this part right here, because that's where 7 that's the part that 7 is in. 7 is in this part of its domain. And so when I take the derivative, so I'll first just find W prime of t. It's kind of always best to just state what the general rule is on an AP exam before you plug in the value. So I take the derivative of 6 is 0, and I'll do the power rule here where I'll bring the 2 down, so that's going to be 2/8, which is the same thing as 1/4, and then t minus 4 to the 1 power. I'll subtract 1 from that. And then as for the chain rule, the derivative of the inside is 1. So I'm not going to worry about that part right there. So that's W prime of t. W prime of 7 would be equal to 1/4 times by 7 minus 4, which is going to be equal to 3/4 if I'm doing that correctly. So 3/4 right there. And I guess I could always just double check, but I kind of don't want to. So W prime of 7 is 3/4. Now we have to use correct units and explain the meaning of what W prime of 7 is in the context of the problem. And so W of t is the depth of water, and the independent variable is in hours. And so when I take the derivative, we're taking the derivative, so the change of the depth of water per hour is what the units are going to be. So I'll say this right here. So W prime of 7 is equal to 3/4. No, I'm not going to write that right there. I'll say W prime of 7 is we can say the change. We can say the rate of change, I guess would be better. The rate of change. The rate of change of the depth of water, per hour at t equals 7 hours is 3/4 feet. Is it feet that we're being measured in? Yeah, feet per hour. It doesn't really sound really good. Let's double check this right here. So W prime of 7 is the rate of change of, I guess I don't really need to say this right here. I'll say this. W prime of 7 is the rate of change in feet per hour. It's the rate of change. Yeah, I don't really like how I said that right there. The W prime of 7, which I know is 3/4, is the rate of change in feet per hour. In feet per hour at t equals 7 hours. So W prime of 7 is the rate of change in feet per hour at t equals 7 hours. Trying to think if I should add in words like increasing or decreasing. So W prime of 7 is the rate of change in feet per hour. Yeah. I probably started it off pretty wrong, and that's why I can't get it to sound as good as I want it to, but let's just say this right here. You should have the answer you should have the derivative as well. You should have, in terms of like what you need to show in the explanation, is you should have feet per hour, because they do say use correct units. You should have words like rate of change at t equals 7 hours. I'll say here it is increasing, just because I really don't know how to write well. Is increasing. And so just in case I need to include that, but I don't think I need to include that, as long as I say that it's the rate of change, indicating that it's changing. So W prime 7 is the rate of change. I don't know, I kind of wish I wouldn't have wrote this right here. I would have probably, going back, would have said something like, the rate of change of the water in feet per hour is changing. Oh man, I don't even know. Something like this right here should be okay though. All right, for 17, or for the second part, the graph of W is concave up from 2 to 2.5. Use the line tangent to the graph of W at t equals 2 to show that W of 2.5 is greater than or equal to 6. So I'll start here just finding the tangent line. That's got to be worth a point, right? So if I need a tangent line, so y minus y1 equal to m times by x minus x1, we know that we're going to do it at t equals 2, so that's what x1 is going to be. To find y1, we need to plug 2 into the function. So we need to plug 2 up here into this part of its domain, so I'll plug in 2 right there. And so W of 2 is going to be equal to 32 fifths plus 2 fifths times by cosine of, that's going to reduce to pi halves. So when I plug 2 right here, that's going to be 2 pi over 4, which is just pi halves. Cosine of pi halves is 0. And so that means that W of 2 is just going to be equal to 32 fifths. I also need W prime of 2. So W prime of t, now the W prime here won't be the same as W prime here because I'm using a different part. So when I take the derivative, that's going to be 0. When I take the derivative of this part right here, I don't have to use the product rule because 2 fifths is just a constant. So I just need to multiply whatever the derivative of this is right here and then multiply it by 2 fifths. So I'll have 2 fifths and then times by, it's going to become negative. So let me write this. So negative 2 fifths. The reason why I'm going to put the negative here is because the derivative of cosine is sine. So sine of pi t over 4, and I'm going to multiply by pi over 4 for the chain rule. So that's the derivative of the inside. The derivative of pi t over 4 is pi over 4, since that's the constant and t is linear. All right, and then I can even I'll simplify it whenever I plug in 2. So to find the slope here, so it's going to be, so I have this negative 2 fifths that's being multiplied by pi over 4. Now, whenever I multiply these together, the 2 over 4 can simplify because 2 fourths is 1/2. So this should just become, the constant should just become negative pi over 10. And then I'm going to have sine, and when I plug in 2 right here, that's going to become pi halves. And sine of pi halves is 1. So W prime of 2 is equal to negative pi over 10. So as for the tangent line, that's going to be y minus 32 fifths equal to negative pi over 10. And then we're going to have x minus 2. So here is our tangent line. And we're going to use linearization to approximate the value of W 2.5, and we have to show that it's greater than or equal to 6. And so what we're going to do is plug in 2.5, not into the function, we're plugging in 2.5 into our linear line. I'm going to move this 32 fifths over here, so I'll get y is equal to negative pi over 10, and then when I plug in 2.5, this is going to become 1/2. So 2.5 plugged in here is going to be 2.5 minus 2, which is 1/2. And then we're going to add 32/5. And then this is going to be equal to negative pi over 20 plus 32/5. Now, 32/5 is like 6.4, I think. 32, my calculator's struggling. 32/5, yeah, it's 6.4. And then, I guess I could, negative pi over 20 is pretty small, but it's less than 0.4. So if you think about this is 6.4. Pi is close enough to be 3, so 3 over 20 should be less than like a fourth, maybe even a fifth. Yeah, something like that. But in any case, 6.4, this right here is not large enough. So whenever I subtract it from 6.4, it's not large enough to make it less than 6. And so here's my explanation here. I'll show an image, but you can't justify your explanation just with an image. But we have a curve W, and W is concave up in this interval. So like on an interval from 2 to 2.5, we know that the curve has a concave up shape. And we have a tangent line at 2. Our tangent line is at 2, and I'm realizing I'm kind of doing this wrong right here. So how about this right here? So our concave up. So from 2 to 2.5, we have a concave up curve, and now I'm drawing it like this instead because I can see from our tangent line the slope at 2 was negative. So that's why I'm adjusting my picture right here. So we have this right here. Again, this isn't really that accurate to what it probably does look like, but whatever. And so we have our tangent line. We plugged in 2.5, but we plugged 2.5 into our tangent line. And so we found right here that on the tangent line, this was 6 point something, but it is greater than 6. So whatever this is, this value right here, it is greater than 6. It's greater than 6. Okay, now we're trying to prove that W 2.5, we're trying to prove that this value right here, this right here is the point of W 2.5. So because we know that we have a tangent line, and because the curve is concave up, that means the tangent line is going to be used as an under approximation. So values on the tangent line are under approximating the values on the curve. And so if it's an underestimate, and our underestimate is showing greater than 6, then W 2.5 is also definitely going to be greater than 6. And so we have to say something along those lines, but we can say that because the tangent line, I don't even know what I just spelled right there. Because the tangent line, no, let's say this right here. Because W is concave up on the interval from 2 to 2.5, then the tangent line at t equals 2 is an underestimate. The tangent line at t equals 2 provides because concave up, the tangent line at t equals 2 is used as an underestimate, I guess I'll say, is used as an underestimate. And so W 2.5 has to be greater than negative pi over 20 plus 32 over 5, which is greater than 6. Let's see if that sounds good. Let me read it over again. Because W is concave up on this interval right here, then the tangent line at t equals 2 is used as an underestimate, and so W2.5 has to be greater than the value that we got from the tangent line approximation, and this value is greater than 6. And so I think that holds true. Okay, and for the last part, we have a limit. So now this is going to be on L'Hopital's rule, so telling you ahead of time that you have to answer this in the free response format. So what I'm going to do is show the limit as t approaches 2, w of t minus t squared minus 12 fifths, and then that's going to be equal to, now we're going to evaluate w of 2. We already evaluated w of 2 up here, so it's equal to 32 fifths minus 4 minus 12 fifths, which is going to be equal to, now I'm going to change this to be 20 fifths, so 32 over 5 minus 20 over 5 minus 12 over 5, which is going to be equal to 0, because we have 32 minus 20 minus 12. So there's the numerator. Then we'll show the limit as t approaches 2 of t minus 2, which is 2 minus 2, which is 0. So now I can use L'Hopital's rule. So L'Hopital's rule, so I can say that the limit as t approaches 2 of w prime of t minus 2t over 1, and that's going to be equal to w prime of 2 minus 4, and w prime of 2, which we found up here. So that's going to be equal to negative pi over 10 minus 4, and you can leave your answer just like that. And that should do it for this FRQ.